Okay, so now I'm ready for my next test, which is the broken tablets. So I have my tablets broken into pieces here, and once again I need to pour in 200 milliliters of tap water, or lukewarm water. Oops, spilling some. You should have paper towels. And I want to make sure it's exact. All right, so we're going to again add in the water, and we're going to start our timer and figure out how long it takes for the 4 to dissolve. So I'm going to get these 4 in my hand here, and then drop them in and start the time. Come up from the top. So we're going to see, is it faster or slower to have the pieces broken up? And they're almost there. How exciting is science, huh? And just teeny little pieces left, and gone. So that came up to 35 seconds exactly. So that's very similar to our third trial there with the whole tablet. So let's do it a couple more times and see what our results are. So for trial number 1, broken tablet, let's add 35 seconds. Alright, so I just did it a second time and my result was 35, and go ahead and put 0.8 since it was pretty close to the first number. So now in terms of our data table, we have 35 for our first trial, 35.8, and so let's go ahead and do it one more time. So I'm going to clear my stopwatch. Okay, I'm going to pour in my 200 milliliters, and I have my 4 tablets here. All right, I'm going to drop them in. 1, 2, 3. Keeping track with my timer. Lots of carbon dioxide being produced. It's getting close. And now, that was a little quicker. So I'd say it was 33 that time. So go ahead and record 33 on your data table and calculate the average. Alright, so now we've done a whole tablet, a broken tablet, and now it's time to move to our powdered tablet. And so I'm going to give it a little shake because it's got a little moisture here. In fact, I think what I'm going to do is crush it up a little bit. You might have this problem too. Make sure it's nice and broken up with my very scientific tool here. Alright, so the directions say to do this procedure is slightly different. That is important. I want to make sure I can get as much of that powder in there. So they say to add it first and then the water immediately following. So I'm going to have to be pretty quick about this. I have my water ready with 200 milliliters. I have my container. So I'm going to put this down and we're going to work with this really fast here if I can. So I'm going to put the powder in and then add the water. And here I go. I think it's already dissolved. So that was very quick. I barely had time to get my stopwatch going, but it's dissolved. So I have 4.34. Probably is a little less than that, but my reflexes weren't quite that fast. So let's go ahead and put 4 down on our data sheet, and let's do that 2 more times. I'm going to try to get a partner and be a little quicker. So that was a very quick result. So let's go ahead and try it 2 more times to make sure these results were not unusual. Okay, I just did it again and I got 4.25. So this is definitely a quick reaction. So I'm going to once again do it so that you guys can watch. So I'm going to quickly put my powder in, And then add my water, start my timer, and it's pretty much dissolved. So that time I 3.69. So happened very quickly, all dissolved. So go ahead and write down 3.69 and calculate your average. Okay, so now we have our data tables complete. So we can look at our results. Our whole tablet took approximately 40 seconds to dissolve. Our broken tablet approximately 35 seconds. And our powdered tablet is the winner with only 4 seconds or less to dissolve. So now what we need to do is create a graph, which is what this is for. Now graphs do not need tails. I don't know why it says that, silly typo. So go ahead and change that to titles. So as you can see, there's no title and the axes are not labeled. So let me give you a suggestion on how to do that. So first of all, you want to definitely give your graph a title of some sort, something probably to do with Alka-Seltzer and dissolving. And I've decided to have on my x-axis the physical size, and I'm going to use the averages. So I'm going to have whole, broken, and powdered, and my average results graphed. And then on the side, I'm going to go ahead and have the seconds. Now, do you want each box to be worth 1 or perhaps something else? So what you do to determine the units is to look at your highest number you want to graph. So in this case, my highest number is a 40. So I need at least 40 points in order to graph that average. So do I have 40 little boxes here? I'm not sure. So what I might want to do is call each box 2, or maybe each box 5. So it would be 2, 4, 6, 8, 10, and so forth. And that way 40 would be somewhere maybe around here to graph, which I think is much more manageable. So go ahead and take a moment now to label your axes and give your graph a title. So if you want to make it similar to mine, that's fine. Physical size, seconds, maybe by 2s, and then your title. So I'm just showing this as a quick example. I want yours to be much prettier than mine. But what I decided to do was for my whole, I'm going to use 3 boxes to make my bar graph, just so I can make it a little wider. If it's just one skinny little box, that's no fun. So I'm going to make a nice big, maybe 3 boxes, 4 boxes across, and make a nice bar graph. And I would go up all the way to 39.7 or about 40. For my broken, I'm going to again take the average, 34.6, 35, and then again make a nice beautiful bar graph, maybe 3 boxes across. And then for powdered, only 4, so it's going to stop right about there. So go ahead and take a moment, get some colored pencils, some crayons, and make a beautiful graph for me. Okay, the last step, we're almost done, is to write your conclusion. Now, do you remember on page 1 where you wrote your hypothesis? So go back and look at your hypothesis. What did you think would happen? Did you think the whole tablet would dissolve faster, the broken, or the powdered? Were you right or were you wrong? So go ahead and write your conclusion. Now, if you notice, this is a little teacher trick. If your teacher provides all these lines, they don't want you to say, I was right, or I was wrong. They want you to write an explanation. They want you to write about your results in words. So go back to your graph, go back to your data table, and in words, tell me what you observed. Tell me in detail, what did you see? What did you notice? What did you record when it was dissolving the whole tablet, or when it was dissolving the broken tablet or the powdered tablet? So I want quite a detailed explanation in words of your results. So I know we can read at the data table and the graph, but your conclusion is where you write your results in words. And you also want to include if you were right or if you were wrong. And then at the bottom is an analysis. It's going to ask you some questions. I'm not going to give you the answers. I want you to think about that a little bit. And then I do have one little challenge. On the back, I'd love you to write something called recommendations. Now, what recommendations are is what you would do differently to make this experiment even better. There were a lot of flaws in my experiment. What would you do differently? For example, one tip might be to do more trials. That might be a way to make this experiment even better. I would love you to come up with at least 2 ways this experiment could be improved. So on the back, I want you to add that. So go ahead, write your conclusion, do your analysis, and give me 2 recommendations on how this experiment could be better. Thanks for watching, and I'll see you at our next lab, the Density Lab.